$4.99, let's go. So in the file 896 section, we have finished slow copy GPU to disk. These are our pixel locations as a byte address, and these are the bit selections. So we want to copy the bits of the pixel from the GPU to the bits of the pixel on the disk memory. Here's aliases for GPU and disk memory, and the first thing we need to do is take the bytes of the GPU pixel, smash them together into a 32-bit integer, take the bytes of the disk pixel, smash them together into a 32-bit integer. B32 stands for bits 32. It'll be the composite pixel value representing smashing together this and smashing together this into a final composite. GPU keep is a mask that allows us to keep the bits within this range, and disk delete is a mask that is going to delete the bits in this range because we need to widen open a slot in the disk memory pixel so that we can insert the bits between this range into our final composite, right? So we're emptying out a slot in the disk memory pixel, and we're going to insert binary data from the GPU pixel into the disk memory slot. So I don't have enough time to explain that all. Anyways, how much are we going to shift the sorry, not the disk memory, the GPU. Yeah, GPU. How much are we going to shift the GPU bits by so that they'll fall into the slot we need? Well, to calculate that, we want a vector pointing from GPU to disk. So disk NB1 minus GPU NB1 is going to give us the shift amount. We're going to error check it right here by just doing the formula again with the NB zeros. And then if the shift is positive, then we are going to erase certain bits out of the GPU memory and shift into place, erase certain bits out of the disk memory, and not shift at all because we're just leaving ourselves a hole here. So when we shift this by the correct amount, that the bits that remain here are going to drop into place into the disk memory bits. Now, if the shift amount is negative, we're going to do the exact same math right here, but we're just shifting in the opposite direction, and we're boring out a hole in the disk memory here. Okay, then all we gotta do is smash it together and do an unsigned shift, so it's interpreted as unsigned logic, and then we are going to extract the individual bytes and place them back into the disk memory here. We also do need to finish this function here, but we're gonna finish this function in a different video. So like, subscribe, send money in the mail. I am Kanji Coder.